Hi, everyone. Welcome to a talk on switching from DynamoDB to Cloud Bigtable and Cloud Spanner. We had a lot of learnings and we had a lot of fun when we ended up migrating from AWS to Google Cloud, and we'd like to share our experiences with you. My name is Venkatesh Ramaswamy. I work for ShareChat, and my co-presenter is Vishal Parpia, who works for CloudCover. We'll talk a little bit about who we are and what we do, and fundamental reasons as to why you would choose a migration. Some of the choice of database and decisions that we ended up going through, some of the key design and architectural principles as well. Some of the details around data migration, batch and stream processing would also be discussed. We will delve a little bit on performance and audit and why those are important, and finally end up with some of the learnings that we had through the process. A little bit on who we are and what we do. Let me talk about ShareChat, the company that I work for. We were founded in 2015, and our latest Series G funding was led by Twitter in August of 2019. We are India's homegrown and one of the largest social media platforms out there where we don't offer English as an option. As of latest, we have about 150 million active users on our website. We exist because there is a fundamental disconnect between the choice that a lot of users in India want versus what's available out there. If you see the users in tier 2 and tier 3 cities in India, a lot of them are not comfortable in conversing in English because that's not their native language. So we give them the language of their choice that they could use to end up interacting, conversing, and sharing social media posts with people around them. Very recently, we also launched Moj, a short video app that we will spend a little bit of limelight towards the end of this presentation. I'll now hand it over to Vishal to talk about him and his company.
Thanks, Venkatesh. So I'm Vishal. I'm the CEO and co-founder for CloudCover. We are a premier partner with Google Cloud, and we specialize in moving companies like ShareChat from one cloud to the other or from their data center to the cloud. Our core focus is on agile enterprises and scale startups, and we use a lot of new technology, including cloud native tech, in order to make that happen with DevOps and data engineering. So I'm going to talk specifically about what we did with ShareChat, and at a very high level, it always looks really easy. On both AWS and Google Cloud, you effectively have an app, a service, and a database. But as we all know, the devil is in the details. And I'm going to hand it back to Venkatesh to give you a little bit of insight as to the unique challenges that we faced in this particular migration.
Thanks, Vishal. As we end up looking at what you need to do when you move from one cloud system to the other, you have to look at the fundamental challenges that you would encounter. In our case, we were on ECS and we wanted to be completely on GKE when we would finish the migration process. CloudWatch was our choice for all the logging and monitoring on AWS. On Google, it would have to be Stackdriver logging and monitoring, with the key note that we would need 100% of it to be available on day one for our observability requirements. On AWS, we were completely on Elasticache using Redis as a storage engine. On Google Cloud, we would want to end up being on managed Redis. And even though they were sort of almost the same company, it is not exactly apples to apples, and that's something that we had to contend with. Now, data migration is a very key piece of the entire process, and we were sure that we had to need 100% of our data, even when a single user had to be migrated over from AWS to Google Cloud. Ultimately, we needed a service mesh integration to get better insights into our inter-service dependencies, and we had to do all of this with zero downtime. When you start your migration and get through the process, it's like drinking from a fire hose. We hope to share with you some of our key learnings, some of our key challenges through the next set of slides to make sure that you are not in the same situation and you do a much better job with all the learnings and challenges that we ended up going through. So let's fundamentally ask ourselves, why should we migrate? Let me walk you through some of the thoughts that we had, which started at around mid of last year, where we were hitting limitations of scale with DynamoDB. Now, we partially solved them through the use of DAGs, but they were just not good enough. We were still hitting a lot of challenges during peak times. So when we ended up looking deeper into what we had to do, we came to the conclusion along with consultation from AWS, that we had to rewrite a lot of our key and core systems. Now, in that situation, we wondered, was there another option? Was there something we could do from the ground up? And should we look at moving to another cloud provider when ultimately the set of changes that we need to do were pretty dramatic to begin with? The other key factor was that we had to save costs. And this was extremely important given the kind of scale and the kind of traffic that we had. We also were looking for a very key and strategic partner for our long-term set of challenges that we would ultimately end up encountering. And we had very unique use cases that we were encountering month after month. Ultimately, we needed a platform for innovation. And that's why we looked across the board, and Google Cloud came out tops in our evaluation as to the platform of choice. Let me give you a little bit of the stats and go over some of the key stats on our existing system using DynamoDB. We had a total of about 200 and odd tables that we had to migrate and about 80 terabytes of data. As an example, a single table had close to about 17 secondary indexes. Obviously not extremely optimized, but something that we had to account for when we end up doing the migration. At peak, our total read units were at about 5 million QPS. And that was a lot of data that we had to contend and make sure that we don't take a hit. And ultimately, our read and write latencies were at the order of about 6 milliseconds. And that's a very critical number that we could not compromise on. Let's start with the choice of databases. And ultimately, here's our learning, right? For any migration, you have to make sure that the data considerations are taken care of from day one. You solve for the data, and I can almost guarantee that the bulk of your problems and your pain points will be automatically taken care of. So there's one learning that you want to take away, it probably is that. Now, we had a polyglot setup in our systems. We had a lot of DynamoDB, a lot of Redis, Mongo, Cassandra, Elastic S3, you name it, we had it. And we also needed a NoSQL that would support secondary indexes. So we had fundamentally 4 choices that we could end up choosing from. Choice number 1, we could go with a single cloud managed database. Life is easy. We could just make one choice and move on. Choice number 2, we could still make a single choice, but this time we would choose a self-managed database completely to be taken care of from our end. Choice number 3 would be a hybrid solution, but optimized for cost. And ultimately, the 4th choice would be another hybrid solution, but optimized for long-term maintainability. Looking at option 1 and option 2, it's a very clear choice between choosing a single database that's provided by cloud, that's cloud native, which is very easy to migrate, but would it be extremely complex for some use cases where you don't need all that functionality? Or would you want to go self-managed, where you would take on the burden of maintaining all the different databases, you would have hired experts? But in my opinion, a self-managed database actually nullifies the impact and the benefits of why you would actually choose cloud in the first place. It's useful for a lot of situations, but not in our use case. If you look at option 3, one of the things we could do was for all our index and secondary index needs, we could choose and store them in a database that actually supported that. In this case, that would be Cloud Spanner. And all the raw data, the data on the leaf nodes, we could store it in a database that didn't require any special indexing requirements, which would be Cloud Bigtable. So the data in a single table would be split across 2 tables. This would make reads and writes a little interesting and would require applications or at least a layer to handle those reads and writes interestingly on the app side of things instead of the database side of things. Let's look at option 4, which is ultimately what we ended up choosing. This is getting the database to do what it's really good at. So we ended up using Cloud Bigtable for all our single index database requirements, table requirements, and storage requirements. And we used Cloud Spanner for all the requirements where you needed more than a single index. So this allowed us to end up using the database for what it was built for what it was really good at, and taking and moving the burden from the application owners to the databases and leveraging them for what they are really good at. We'll talk a little bit about the key design and architectural principles. For that, I want to have Vishal come and spend some time.
Thanks, Venkatesh. So after we helped ShareChat to figure out which options worked best for their specific use case, we had to then get into the actual design of how we would make these work and how we would actually enact the migration itself. The concept that made sense for us over here was to use a data abstraction layer. Now, a data abstraction layer is a fairly common design pattern in software engineering, and it also takes the guise of something like a middleware. In the case of ShareChat, they were already using libraries internally to kind of obfuscate DynamoDB and provide that functionality to the application. So we wanted to take advantage of that. The traditional approach would have had the data abstraction layer live inside of the service, so literally inside the code. But because we were moving to Kubernetes, we had the opportunity of using a sidecar approach to make the same thing happen. And this gave us a few really key benefits that we would have otherwise not been able to get. This modified sidecar approach effectively took the shape of a database driver that ran as a sidecar process and allowed us to do things like connection pooling for the pod. We were also able to do a single driver for multiple different kinds of languages and just have a different library that would interact with it over gRPC. And this obviously gave us a dramatic performance increase in terms of the kind of code that we were running, because we wrote everything in Go. And it also allows us to, in the future, potentially change the database redirections. And this pattern worked so well that we're actually going to open source this with Google as well. The critical piece over here, though, was that ShareChat didn't need to change anything inside their application layer at all. They just need to swap out the library that was being used to access the database. And this gave us an enormous benefit in terms of the speed with which we could actually make this migration occur. So I'm going to talk about that migration in a little bit more detail. This was obviously a fairly gargantuan task. As you saw with the earlier slides that Venkatesh showed you, we were talking about a substantial number of both tables as well as data. And in order for us to be able to move this over from AWS to Google in a repeatable and reliable manner, we had to use a multi-stage process. So the three phases that we ended up with effectively looked like this. We had a starting with a batch of an upload of all of the data until a specific point in time. And at the moment that we actually started that dump of data from DynamoDB, we also started inserting all mutations that occurred to the DynamoDB tables into PubSub. We were going to use that in T1, which was basically after we were done with the load, we wanted to be able to play back all the changes that happened to the database after we had loaded that point in time snapshot. Following that, and this is the most crucial phase, when we were actually sort of in sync, we wanted to be able to start streaming data directly from AWS to Google. And this was probably one of the most complicated parts of the entire system, because we couldn't use PubSub to do this. We had to build our own system to enable that kind of streaming from DynamoDB directly into both Cloud Bigtable and Cloud Spanner. So let's talk about the batch processing. So we took exports of the table data from DynamoDB, which ended up inside S3, and we would basically watch and consume those and stuff them into an SQS queue that would be processed by EC2 instances that would both compress and transfer that over to GCS. On the Google side, we were watching and consuming those buckets through Cloud Functions that were triggering individual DAGs inside of Airflow, which was running on Cloud Composer, that would run on top of data flow multiple jobs to both load data into Cloud Spanner as well as Cloud Bigtable simultaneously. And this obviously was dependent upon the configurations that we had as to which table went into which system on the basis of where the indexes were. So all of the tables that had multiple indexes would end up in Cloud Spanner, and all the tables that had single indexes would end up in Cloud Bigtable and give us better performance. The load process itself was also extremely complicated. As you can imagine, firstly, we're trying to take data that's inside a NoSQL system and put it inside a SQL system in the case of Cloud Spanner. That required us to actually add missing columns when we detected them inside the data that we were getting. Because a lot of this was legacy data, there weren't very stable schemas, and taking advantage of NoSQL allows you to effectively create keys and values as you see fit. Well, that information wasn't present when we dumped the data in some kind of format that would allow us to create the tables before we did the transfer. So we had to actually do that on the fly. So the code that we wrote inside Dataflow would actually process all of those individual rows and add the appropriate tables, column families, and missing columns as required. We also had a dead letter pattern that dealt with rejected records and allowed us to retry them after we had made the appropriate changes to either the data type or the schema itself. Once we were done with that initial transfer, we had to switch to doing the stream processing. This is where it started getting really interesting. So in order to make this happen, we used a system on DynamoDB called DynamoDB Streams. Now, what that does is it effectively puts all the mutations that are happening inside DynamoDB into a stream that can be consumed, and it retains the data for about 24 hours. The Lambda functions that get triggered on the back of that had to be configured because it got really expensive really fast. So we set those up so that they would take batches of 10,000 records in 5-minute intervals and push those over to some custom code that we wrote on the Google side, running on Compute Engine, written in Golang, that would allow us to both push the data in real time into Cloud Spanner and Cloud Bigtable, depending upon the configurations that we had in place. And this is really what allowed us to do this. We tried to use PubSub, and there were multiple concerns that we ran into with that. Some of them were latency related, and some of them were related to ordering of the records in order to make sure that it was going into the database systems at the right time. As you can imagine, latency and performance is absolutely key over here. And we actually built a whole bunch of interesting code to be able to manage any kind of breaks that might occur in the stream itself. So after we were done with that transfer, it fell to our team to make sure that Venkatesh was happy with the outcome. And that meant making sure that the data actually matched on both systems. And that's where this comes in. Venkatesh?
Thanks, Vishal. Performance and audit are two understated steps in any migration process. They never get the due diligence. And I want to talk a little bit about what we did to end up focusing on these two aspects. So you always start with data that's publicly available, right? It's great to have data, which is a starting point, but you make sure that you verify them. So what we did was to set up a dummy setup in our staging environment. So in this example that I have for you, we had a 40-node cluster for a real table called tag posts, which was set up on Spanner, which had about 160 GB of data with about 5 indexes. And we hammered it with a read-write ratio of a 4:1. This allowed us to see how the Spanner table actually scaled with the amount of traffic that it was getting and what was its breaking point. And once you had that, the next key part and the most important part is to try the same in production. And the reason for that is your physical setup for staging and production are going to be fundamentally different. And you do this and you rinse and repeat for most of the key flows and the key tables that you would expect to hit a lot of traffic during normal and during peak times. And this would give you a lot of comfort when you turn on the migration step completely onto one side. The two different audit parts that are important for any migration are one for streaming and the other, which we will talk about in the next slide. For streaming, it's extremely important for us to make sure that the data has been caught up from the source and the system of truth to the new system that is under test. In this case, AWS was the source of truth and Google Cloud would be the system under test. So the graph that you have in front of you was data that we got from Influx, which we were ending up inserting into and visualizing Grafana. So you see that initially at time t equal to 0, you have about 18 to 19 hours of lag. And ultimately it takes about 6 hours for the data to actually catch up and get closed down to 0 as much as possible. Again, you do this for your key metrics, for your key tables, and these are extremely important to have at your disposal to make sure that your business metrics are doing as well as your system metrics. Now, looking at audit for data consistency, the way we did this was to make sure that we replayed the events that were happening on AWS, on Google Cloud, and did a simple JSON diff of the two response objects that we got back. And if there were any differences, we would end up logging that. So the values that you see here are real values that we got when we initially started out our migration processes. And this allowed us to make sure that we fix this, we take care of this, we handle this before we shift even the first user over. And that gave us the confidence to go extremely confidently to business and say, you know what, the system is as good as the business metrics, and we should not see any perceptible impact on users as they end up moving from one system to the other. And ultimately, I want to focus a little bit on learnings. But before that, I want to start off with a small story, which started at around the first week of July, not too long ago. where we launched our short video app called Moch, which took just about 30 hours from ideation to the actual launch. And guess what? We were all ready. Google Cloud was ready for us in terms of scale, in terms of the kind of traffic that we were expecting. Around the same time, because of geopolitical reasons, our traffic on the ShareChat app also went astronomical. We went to almost 3x, 4x the amount of data that we were typically used to. And we didn't even blink an eye. We were able to horizontally scale with zero to minimal code changes. Close enough, about a week from then, we made the decision to move all of the traffic for Moj, which was quite a bit, onto Singapore. And all this really happened behind the scenes seamlessly, thanks to the amazing support from Google that we ended up receiving. Care for the minimal changes that we had to do on the DNS entries. We really didn't have much in terms of challenges that we faced during that shift over. And ultimately, it's kudos to everybody who has been involved in this. And I wanted to use this as the poster child for the benefits that we have gotten just 3 months after the migration process. And ultimately, the learnings from the migration itself. I think it's important to know that the migration or any migration of this nature is not going to be a linear path. You could plan for all you want, you could build all the contingencies in place, you would still end up encountering things of the unknown nature, and you just have to fight your way through it. But what's very key and important is the top-down ownership and the commitment that you need to have to make sure to get through all these challenges that will come your way, and sign up for long weekends and nights that will ultimately be the outcome. Solve your DB choices first. Extremely important, right? I've mentioned this before. I'm going to keep mentioning this. Your data is going to be the ultimate decider of how good your migration process is. Your data doesn't get moved correctly, you're going to have a number of challenges, even with all the computes in place, even with all the scalability in place. And then ultimately separate out your migration and your optimization tasks. A lot of the people would want to end up doing one step of the migration process, then ending up putting an optimization step on top of that. It doesn't work very well. In fact, it's chaotic. It's extremely disastrous. We didn't do it, and we would never do it, even if you have to redo this all over again. There's a lot of learnings, but the key part is separate them out. Make sure that you focus on the migration. If you have cost concerns, talk to Google, talk to your cloud provider. I'm sure they'll have a path forward for you guys. And ultimately, work as a single team, folks. I can't emphasize this enough. We had a lot of different parties associated with this. We had developers, we had the Google PSO team, we had actual Google engineers from Spanner, from Bigtable, from core engineering teams. We had our set of consultants. We had CloudCover, who was our partner in crime. And we worked as a single unit, which means that if I had feedback to give, I would not just give it to my folks, I would give it to everybody involved. So finally, I want to thank all these people involved. An amazing set of aligned work, amazingly focused set of people that were involved in this process. It would be impossible to end up thanking everybody that made this possible, but I still want to give out my heartfelt thanks from both me and Vishal for making this a reality. Thank you, folks. Thank you for everything.